Today I'm going to lead the discussion. We're going to talk about logic puzzles. So the point of this discussion is more that so that it doesn't matter if you guys get the answer right. I want to hear more about your thought process, because that's more important. So while we're doing this, improve your problem solving skills. And then especially when you guys do your videos, you guys have give an explanation of what your project does, right? This helps you verbalize what you're going to say, so you don't stutter and everything. And then also in a lot of well, in my experience, a lot of engineering interviews, they ask you these logic puzzles, not because they want you to see you get the answer right, but it's about how you think. That's what's most important here. So, any questions about what logic puzzles are? We're gonna go through examples. All right. So our first example is called the pirate logic problem. So we have 5 pirates, right? They're called Maro, Bart, Charlotte, Daniel, and Eliza. And so they're pirates, and they find 100 gold coins. Okay. And so the point of this logic puzzle is, they want to figure out how to divvy up the gold, right? And they each want to maximize the amount of gold they get. But so it starts they go in order of how they want to propose the split, starting with the captain, Amaro. He's going to propose how he's going to split up the gold, and they get to vote on it. If there's a tie or there's a majority vote, then that plan goes through. Does that make sense so far? Right. So, but if if more people say no, then the captain gets killed off, and then the next person goes in line. So then if they don't agree with Amaro's plan, Bart will decide how to split up the gold, okay? And so on until Lisa's the last one standing, right? And so just to be clear, for a plan to go through, there either has to be a tie or a majority vote for yes. Everybody makes sense so far? So these are the rules for now. Right, he makes a proposal for 100 points, talk about that. And so yeah, each pirate wants to stay alive. That's pretty key. And they want to maximize the amount of gold they get. Yeah, they get to vote on the plan, and sorry guys. Yeah. And everybody knows that everybody wants to stay alive and maximize their profits. They can't collaborate, and everybody makes a perfect decision based on logic. All right. So how should the captain propose to split up the gold so that everybody stays alive, and he stays alive, and he gets the most gold? Does that make sense so far? Does the ground rules make sense to you guys? Any questions?
How much time do we get to solve it?
No, well, this is the part where we discuss. Any questions about the problem so far? Yes?
Does the captain get a vote?
What?
Does the captain get a vote?
Yes, everybody gets a vote. So, what are you guys' thoughts so far?
How many people are there?
5. Ben?
You start with the last person and work your way back.
Wait, hold up. Wait, I gotta preface this. If you guys know the actual solution to this, which is possible, don't say it. But yeah, what is your thought process? Have you seen this problem before?
Yeah.
Okay, never mind. Forgot to say that. But yeah, anybody else have thoughts? This is a discussion, guys. I need you guys to speak up. Yes, Matthew.
You get a tie.
What?
You get a tie with 5 people.
I mean, imagine if the captain got killed off and there's 4 people.
Oh.
Yes, Kian?
Captain proposes that he gets 40 pieces, and then Daniel and Eliza get 30 pieces each. Would that work? That way they get more than 1/4 each, and he gets the most. And he buys 2 votes along with himself.
That would work, but the captain wants to maximize his profits. He wants to maximize the amount of points he gets.
Okay, in that case, 58 and then 26.
There's actually a higher number you can get. I'll give you guys a clue. The captain can get more than 90 coins.
Can you get 96 coins?
All right, I'm not gonna say yes like these. Yes.
We have 98, that would get 1.
Oh,
That
yeah.
is
That's probably
that is correct. Who gets the other 2 coins?
The next 2 people in line, we're gonna take a plan.
No,
The last 2.
not the last 2.
Middle 2?
No, the third and last.
Why?
Do you know why? All right, you guys just guessing. All right, okay, so I'm gonna explain through the solution with you guys. So how you work through this problem is you start, like as Ben said, you start with the last kids. So imagine if everybody gets killed off except for them two, which is Daniel and Lisa. So this is always going to wind up in a tie, right? Because you only need a tie to win all the coins. And so in his case, he's going to keep all the gold, and Lisa gets no gold at all. And she doesn't want this, right? So she thinks back, all right, what's the most profitable way for me to get at least something out of this, right? Does that make sense so far? How if it's the last person, she doesn't get anything, right? So let's look back one more person. If Charlotte is alive, right? So for her, all she needs to do is guarantee that Elisa will support her. And she knows that if she gets killed off, she stops getting killed. But she stops, if she gets removed, that Lisa won't get any coins at all. So that means it is in Lisa's best interest to support her, right? So all she has to do is offer Lisa 1 coin, and that guarantees her support. Does that make sense so far, based on logic? Okay, and so you move back even one more, then you know that for Bert, it's the same principle for him, because he knows that if he gets voted off, Daniel won't get any money at all, and he knows that the easiest way for him to get support is to offer him 1 piece of gold, which is his plan, right? Which is not in benefit of Charlotte or Lisa, because they get nothing. And if you keep applying this, the number of pirates doesn't really matter. Essentially, the easiest way to do this is the captain just needs to get 2 votes, and he knows that if he gets off the chopping block, Lisa and Charlotte won't get any money at all. So you need to just offer them 1 coin each. Does that make sense? Any questions? Yes.
How many pirates would there have to be so that each person gets, so that most anyone can get is 1 coin?
200, I think. I don't know, it's a lot. But the number of pirates doesn't matter, and the number of coins doesn't matter. It's just based on every other person, you need to offer them 1 coin. So if you have 100 coins, so about 200 people, I think. Yeah? Makes sense to you guys? I need more discussion here. This is discussion, guys.
Why not?
Yeah?
Why would the one person skip the person to the next to them and go to the person 2 over?
Because it's in their best interest for so he knows that he doesn't get, this guy will, Bart, I think that's his name, will most likely not support him no matter what, because he could get a more profitable deal out of having the captain put off, right?
So they do the next person because that'll ensure that they support their plan.
Yeah. Everything makes sense so far?
Yeah.
Okay. I'm gonna need more discussion for this next question, guys. What's up?
I guess when putting it is that if you can break them down into the evens and the odds, and if an odd person's best plan always benefits all the odds, and more than the evens, and an even person's plan always benefits the evens more than the odds. Back to that last case scenario where it's Daniel and Eliza, he is the even, she is the odd, but based on this ordering, and he wins the most. Back to one more, Charlotte's plan, she's the odd, and she and Eliza win. So those 2 win, Daniel loses. Back one more, Bart and Daniel get money, Charlotte and Eliza get evens versus odds, and back to this one against Captain and Odd, plus 2 odds, screwing over the evens.
Yeah, that's exactly right. So these types of logic problems rely on this concept. It's called common knowledge. Essentially, everybody in a group N knows this piece of information A, and everybody else knows that everybody knows A. Does that make sense? That's what common knowledge, right? You guys having a good time? Like a dead crowd. All right, so we're gonna do the next problem. This one's actually way harder. Again, if you know the solution, do not say it. Has everybody heard of the green-eyed, blue-eyed problem?
What?
The green-eyed?
Yes.
No.
All right, raise your hands if you know it. And who knows the solution too? All right, you guys don't say anything. All right, so essentially imagine you're on an island and you have 100 people living on the island, right? They're kept prisoners there. And so,
Wait, are you one of the 100? So there's 101 people?
No, you're not one of the 100 people. I'm just saying this.
101 people on that island.
No, just 100 people. I'm saying there's 100 separate people from you who live on this island and they're imprisoned there, right? And so the only way for them to escape is every night they're gonna approach the guards and ask them, all right, and ask to leave. If they have green eyes, they're allowed to leave. If they have blue eyes, they get dropped into a volcano. All right? And so, as happens, all 100 people of the island have green eyes. Right? The thing is, they've grown up not knowing what their eye color is, and they can't communicate with each other to see what their eye color is. Right? The only thing they know is that they see each other every day, and that's about it. Okay? So one day, you get to go to the island, and like the person who's keeping the prison lets you go talk to them, right? And you only tell them one thing, and you say, at least one of you guys have green eyes. Okay? It's pretty important. He tells everybody at the same time that at least one of you guys have green eyes. And so one thing is, no one will leave unless they're certain they have green eyes. And so after you tell them this, on the 100th morning, all the prisoners are gone and having asked to leave the night before. Okay? So after 100 nights, the 100th morning, all of them are gone because they just asked to leave. So how is this possible? Discussion, please.
Well.
Any ideas?
I don't know.
Question.
Yes, you guys.
So that means that all of them survived.
Yes, all of them survived.
None of them got pushed into the volcano.
None of them got pushed in the volcano because all 100 of them have green eyes.
Wait, so the guy who owns the prison, he tells them only once that one of them has green eyes.
At least one of them have green eyes.
And he says that only once to them.
Yeah.
Okay.
That solution's wrong.
No, it's right.
I'm pretty sure it's wrong.
I'm pretty sure it's right. Yeah, so at least one of them has green eyes. That's like the key. Any other thoughts?
Question. You said the 100th day. Does that mean there's one per day, or does there could be an uneven distribution?
No, they all leave on the 100th night at the same time.
Oh, everyone leaves it.
And
Oh, wait.
I don't know if Victoria can say. So
I thought it was 101 points.
it's the 100th night after you come.
Wait.
What's up?
So if nobody leaves the first night, right?
Mm-hmm.
Then they think that the other people don't have green eyes, and then nobody needs the second night, and then nobody needs the third night. So that the Christmas green eyes doesn't leave. So they wait. So do they know that each other has green eyes?
They each see everybody else has green eyes, but they don't know for sure if they have green eyes.
They know for sure they have green eyes.
Does the guard give the same advice every single day?
No, they just ask him if they could leave, and if they have green eyes, they could leave.
Listen, the guy who says at least one of you has green eyes,
Mm-hmm.
is that said every day?
No.
Oh, just one time?
Yes. Anybody want to chime in? This is discussion, guys. No?
I think it's easier to visualize the case if you isolate 2 prisoners at a time
Yeah.
and you tell them the solution.
All right. Yeah. Let's think about this in this really simple case, right? That's what I was trying to get at, actually.
Oh.
So, let's imagine there are two prisoners, right? Right. They both same thing. They can't communicate each other, but they can see each other, right? And so after you tell them at least one of you guys have green eyes, what's the most logical thing they do? They don't know if they themselves have green eyes, but they see that the other person has green eyes. So,
They wait for the other person to leave.
Did you say something?
Yeah, I just said,
What did you say?
I said they tell the other guy to leave.
They can't communicate.
Can they gesticulate?
They push them on the.
They can do no such thing as communication between each other. They only see each other.
Can they shove each other?
No, that's communication. Yes, man? Speak your mind, man. Nothing's wrong.
Oh, I know the answer.
Ah, yeah. All right, yeah. So, if they both don't know if they have green eyes, right, but they see the other person has green eyes, and they wait one night, what are the 2 cases that could happen?
The other person leaves or the other person stays.
Exactly, right? If one person, if after the first night, the other person disappears, that means the person he's looking at. Imagine, okay, you have Adria and Bill, right? If Adria had green eyes and Bill had brown eyes, right? Adria would see a brown-eyed person, and since the statement is there's at least one person with green eyes, then she knows she has green eyes. Does that make sense?
Yeah.
And so that night she would leave, and Bill would know the next morning that, oh, I have brown eyes, I can't leave.
Wait, you would know that? How would you know that?
Because he says at least one person has green eyes, and then Adria sees a brown-eyed person.
Oh.
Logically, that means she's the only person
Yeah.
with green eyes. Make sense so far?
Yeah.
All right. So, but then if they both stayed that one night, that
they
means
both know that each other has green eyes.
yeah.
Oh, okay. So basically for the bigger puzzle, you just apply that again, and then I'll just go, yeah, okay, that's it.
All right, seems like you understand. But does everybody else understand how your thought process works? Sean, what's your question? You don't seem like you understand.
Hard doing for a socialist experiment.
Yes, sure. Any questions so far? If you don't understand this, speak up. I'm here to answer your questions. Lou? Quietness, yes?
But in the actual one with all 100, everyone sees that each other has green eyes, so none of them has a different color. So is there still...
But they don't know if they themselves have brown eyes. They don't know what they're looking at. They don't know their own eye color. And they will only leave if they're for sure that they have green eyes.
You can see the reflection.
So then what happens on night 2?
There's 3 people.
There's 3 people, okay. Here, there's 3 people actually. Expected this. So imagine there's 3 people, okay? So each of them see the other person's eye color, right? But they're not sure if they're not sure if they themselves are the brown-eyed person, right? So you could apply the same logic again. So imagine there's like Adrian, Bill, and Carl, right? Isolate the 2. So Adrian and Carl, I guess, would look at each other would check if they're there in the morning, right? Well, no, they wouldn't. Okay, well, I'm trying to explain this well. So after the first night, none of them would leave, right? Because if they see one person still around, they still don't know if they themselves are the brown-eyed person, right? Because if you see like 2 green-eyed people, right, or 1 eye green-eyed people, well, I'm trying to, sorry. If they see 2 green-eyed people in the morning, give me a sec, I lost my thought process. Okay, yeah, so if they're only keeping track of 1 person at a time. So if Bill and Adrian watch each other and they both see like a green-eyed in the morning, that means they both know that they both have green eyes. Sorry, someone want to chime in on this? I think I lost my thought
Wait, but
process.
they won't know because the third person.
Yeah, man.
So if there are 2 people and they both have green eyes and they look at each other, then they know that the other one has green eyes, but they don't know what color their own eyes are, so they wait a night. And then in the morning when they wake up and they see that the other person's still there, then they know that they're not sure what color eyes they have. But since they know that the other person already has green eyes, then they know that they must have green eyes because the other person didn't leave.
Exactly. Does everybody hear them? Yeah? That was a great explanation. Points to you, Ben. But yeah, does everyone understand that logic? You can extend this to as many people as possible. And essentially, only about the number of nights correlates to the number of people there are, right? There's 100 people, how many nights would it be? 100, exactly, right. All right. Yeah. So the only thing they don't know is if they're the person being kept track of, right? Because everybody looks at 1 person every single night, checking if they've left or not. Does that make sense so far, guys? Yes? You like this stuff?
The solution that I came up with was instead of waiting 100 nights and saying at least one of you has green eyes, you can say 99 of you.
Yeah, you could say there's different ways of saying it. You can say at least 99.
That'd be
it's
2 nights.
Yeah. But yeah, I'm trying to do really simple. But yeah, that's essentially what I got. I hope you guys like this. I don't know, if there's other logic puzzles that you could actually do, prove p squared minus 1 is divisible by 24. That's a mathematical thing. 13 caves in the thief is called, and then prisoners in a hat puzzle. You guys ever heard of those? Yeah, Victoria seems like you know.
Just be a prime number.
Forgot to put that. Yes, p is a prime number.
Oh,
But you don't really need to know that to know it's divisible by 24.
But divisible by 24? Are you sure?
Yeah, you don't actually need that.
Because that's not true.
It is.
But
I can prove it mathematically.
Think about it. P squared minus 1, right? That can be larger than 24 or it can be less than 24. Either one. It can be larger than or less than 24. Yeah. You can have 3 or you can have 17. 17 squared is larger than 24. 3 squared is less than 24. So what you get is
Alright,
that...
fine, p is prime. Okay, actually, I was wrong. Yeah. But yeah, I can prove that mathematically. Pretty simple.
Can you prove it right now?
Yeah, sure.
But you had to go 1 of 3 or 3. So okay, never mind. Put it.
Huh?
2 and 3 digital prime numbers.
Wait, does P have to be more than like
Yeah.
24?
You cut the video. By the way.
It's, you should might have to be